Hello everyone, welcome back to Unit 3 and 4 methods. And then today we're going to start chapter 5, continuous random variables and the probability of distribution. Um, so this one we're going to be using some anti-differentiation to do with the density of functions. So the probability of density function first, we need to know the function in the domain interval. Um, we have the domain. And so fx is greater than or equal to 0, and all the x in the interval. And also the area will be under the curve, the graph function will be equal to 1, because that means your probability in total is equal to 1. And the domain for the function of x, so c and d, the second condition, so corresponds the d to c, so fx dx equal to 1. So as we know these rules, and then we are gonna using that rule quite often. So we can say uh, this is a probability of the density function of x. Um, so probability from A to B. So we're using the derivative of under the graph, and that's the what the actual meanings between. Okay, so let's start example one first. So first thing first, we need to know the probability of the density function uh, is actually from the cx into 0, so 0 to 2. That's what we know. So we can say the fx dx, so they can equal to 2 to 0 cx dx. And then because 0 is means anything, so which is we can say since fx equal to 0 elsewhere, that means like anywhere except for the 2 to 0. Now what we do is, so we can do the question with 2 to the cx squared, and then from 2 to 0. So now what we do is 2c minus 0, so equal to 2c. So we need to figure out the value of c from fx. So we know our probability, the density function are equal to 1, so that means function x, so equal to 1. So that means 2c equal to 1, c equal to 0.5. So there you go. Uh, Now what we need to know is when figure this out when probability of 1.5 first. So now what we do is question B, the probability x greater than 1.5, that equal to 2 to 1.5 and half x dx. So that means we figure this out is equal to so x over 4 squared 2 to 1.5. So now what we do is 1 minus so now what we know is the 1 minus 1.5, 2.25 divided by 4. So 2.25 divided by 4 equal to, let me just real quick to test out. So 2.25 divided by 4 equal to 0.5625, and then that equal to 0.4375. Perfect. This is how you're gonna calculate if the graph is greater than 1.5 but less than 2. All right, so next example, same ideas. We're gonna sketching the graph first. So 0 to 1, the graph 1.5. So 1.5 minus 1.5 x squared. So fx and then equal to that dash 0 less than equal to x less than equal to 1. The graph for that we need to know is our x-intercept first. So y to 0.5. So 1.5, 0, 1.5, and to 1, actually, to 1, 1, 0. So if the x equal to 1, so that equal to 0. So now you have that. Yep, so that's 1. Yep, perfect. And then x and y. Question B, show the function of a density function. Okay. So now what we do is we're using that graph. Question B. Positive to negative affinity. So positive affinity to negative affinity. That equal to 1 to 0. 1.5 minus 1.5 x squared. And dx. Since x equal to 0, fx equal to 0 elsewhere. Perfect. Now what we do is that equal to, we can get rid of the 1.5 outside. So that equal to, that equal to 1, 0, 1 minus x squared. So that equal to 1.5 x minus x cubed z 1 to 0. So we can say 1.5 1 minus 1/3 minus 0, so that equal to 1.5 times 2/3, so that equal to 1. Yeah. So the second condition holds, hence the probability density, which is this is 1, so which is the whole 100% from 0 to 1. Good. Now we're gonna figure this out. Probability of x greater than 0.5. Same idea. So we're gonna substitution in, or we can use the CAS calculator. So I'll leave this one to you guys to calculate. Question C. Use CAS. All right. So example 3. Now what we do is we're gonna do unbounded domain. So first thing first, we're gonna graphing that. Use a CAS calculator graph, and then please don't try to use by hand because they're gonna take it for a while. So if I graph that one, maybe I just real quick. Oh, that was not straight at all. So we can do y and then x. Perfect. And then what we do is 2e to the negative 2x. That will be the reflection by greater than 0, so which is greater than 0, so that means that's 2. That's 2, 0, 2. So we're going that way. There you go. Perfect. Yep. So that's question A. So question B. Show the function, the probability. Then okay. So the same ideas. So now what we do is we're gonna figure this out. So is this affinity to 0? Yeah. So affinity to 0, and then 2e to the negative 2x dx. We can use some limits. So we can say the limit, the k is going to the affinity. So which is k 0 to e to negative 2x dx. And then that equal to negative e to the negative 2x and k to 0. So we can say negative e to the negative 2k plus the e to the 0. So that equal to 1. So that equal to, so the k can be any number. So they're getting closest to 0. So we can say 1 plus that can be equal to 0 because the k is getting bigger, and that will be getting a little bit harder, so which is 1 plus 0 equal to 1. Yep. Question C. Let's go with question C. So now what we do is greater than 1. So probability of x greater than 1 equal to the limit k to the infinity and k to 1 to e negative 2x 2x dx. Same idea, so we do is negative e to the negative 2k minus e to the, so minus the e to the negative 2. So that equal to 0 plus e to the negative 2. So equal to 1 over e squared. So if you use the CAS calculator, so you can use the CAS to calculate it, and maybe around 0.1415. So I will show you how to do by CAS calculator later. So how we're gonna do this question with CAS calculator, I will show you. And don't panic if you don't know how to do it. That's okay. We can go through with that. Now this question, I want to leave it for you guys to practice by yourself. And let me know if you have any questions. And hopefully you understand this whole 15A. And see you guys next time.